Good morning. We will discuss thermodynamics. So we will learn to predict the spontaneity of a process based on entropy, the second law of thermodynamics and its significance, and Gibbs free energy to determine the direction of a reaction. So, what is thermodynamics? Thermodynamics is the study of the interconversion of heat and other kinds of energy. So we have four laws of thermodynamics. We have zeroth law, first law we have discussed previously, the second law of thermodynamics that we will discuss today, and the third law. So let's focus on the second law of thermodynamics. However, let's have a recall on the first law of thermodynamics. So energy is conserved in the universe, meaning the total energy of an isolated system will remain constant. Energy can be converted from one form to another but not destroyed, and the total energy of the universe is always constant. And whenever the quantity of energy disappears, there will be an exactly equivalent amount of energy that is transformed. So remember, the change in internal energy is equals to heat minus work. How about the second law of thermodynamics? So the entropy of the universe increases in a spontaneous process and remains unchanged in an equilibrium process. So meaning we have two terms that you need to know, entropy and the spontaneous process. So what is a spontaneous process and what is entropy? To know more about the second law of thermodynamics. So spontaneous process is no need of energy. So meaning you don't require energy for it to happen. And for the non-spontaneous, it requires energy for it to happen. So let's have an example. So for the spontaneous process, look at the heel. Now the ball is going down because it is unaided. So meaning the reaction will happen without an energy. And here, look at the man. He is pushing the ball upward. So meaning it applied work. Okay. It requires energy for it to happen. And take note of the Gibbs energy. Later on, we will discuss it more. Why we have positive Gibbs free energy here and a negative for the spontaneous process. So another examples of spontaneous process, we have roasting, ice melting, removal of sugar from a cup of coffee. So what is an entropy? So entropy is a thermodynamic quantity denoted by letter S. It is a measure of the randomness or disorder of the available arrangements for the system or surroundings. So meaning when there is a reaction that will happen from an order to disorderness or disorder or randomness. So it also refers to the number of ways the energy of a system can be dispersed through the motions of its particles. And the SI unit of entropy is joules per Kelvin, and like enthalpy, it is also a state function. So let's have an example here. So for the solid state, what will be the entropy? So remember, entropy is the disorder. Look at the molecules of solid. Will be the entropy of solid will be lowest or highest. So that will be lowest. For the liquid, so that will be intermediate. And for the gas, that will be the highest. Why? Because again, look at the molecules of the gas. Gas has disorder or randomness of the movement of the gas particles. So that is why the entropy for this one is the highest. So the state function, a state function that the value depends on the present state of the system and not on the manner by which the state was reached. So therefore, the change in entropy is equals to the final state minus the initial state. So the change in entropy of a system must be always equal to the difference in entropies of the two states or conditions described by the equation. How do we determine the entropy change that occurs in a substance? By knowing if the reaction will increase or decrease. So, if we have increase in entropy, there will be a formation of gas from the reactant. Decrease in entropy when a gaseous reactant is converted to a solid or liquid, meaning that the state will be converted to solid or liquid. If there is a reduction in this order, there will be synthesis reaction. So meaning when we synthesize, we create a product, we create a compound, na synthesis creation, and increase in this order during a decomposition reaction. So therefore, when the system increases, the entropy or the change in entropy is positive. When the system decreases, the change in entropy is negative. So let's have an example of entropy. The vaporization of water from liquid state to gaseous state. So just like the enthalpy and the internal energy, a positive value of entropy meaning increasing in entropy, and while negative value means a decrease in entropy. Remember that gaseous state has a more highest entropy than the liquid. So the gas or the gaseous state is the final state while the liquid state is the initial state following the equation of the change in entropy. So this process will lead to an increasing entropy. So we have a positive value for entropy. Let's have another example. Predict whether the entropy change of the system is expected to increase or decrease. Here, we have potassium chlorate will produce potassium chloride plus oxygen. So this is a decomposition reaction. So if it is decomposing, therefore the entropy will be increasing. If it is increasing, what will be the sign of entropy? That will also be positive. So let's have another example. We have here hydrogen plus oxygen will produce water. What type of reaction is this? This is synthesis reaction. If we are synthesizing a product or a compound, we have decreasing entropy. And if it is decreasing, the sign will be negative. So with that, second law of thermodynamics, so meaning if the entropy increases, that will be a spontaneous process and remains unchanged in an equilibrium process. So it is also related in the first law of thermodynamics. So with that, for a spontaneous process, we have the entropy of the universe is equal to the system and the surrounding. So this one is greater than 0. So that is why it is increasing. So if the universe, the system, and the surrounding is equal, so therefore we have an equilibrium process. So the change in entropy must be a positive value which corresponds to an increase in entropy. So that's why exothermic and endothermic reactions may be spontaneous. So why? Remember, the enthalpy of the endothermic is positive and the exothermic is negative. But why it is spontaneous process? Spontaneous process does not require work for it to happen, the energy. It is because when heat is released by the reaction, it increases the disorder of the surroundings of the system. Meanwhile, in endothermic reaction, it is also spontaneous process because the disorder within the system increases, which is greater than the surrounding, which will have a positive value for entropy. When we have a positive value for entropy, meaning it is increasing. So now let's go to the entropy change of a reaction. So the exact entropy change can be determined the same way of enthalpy change using the standard absolute entropies. So this is the equation or the formula, product minus reactant. So the summation of product and the summation of the reactant will have or will equal to the change in entropy of a reaction. So let's answer this problem. Calculate the change in entropy at standard state at 25 degrees Celsius that accompanies the reaction. So we have a balance equation of carbon plus carbon dioxide will yield the product of 2 carbon monoxide. So these are the given value for the entropy of each compound or element. And then required is the change in entropy, and the equation is the change in entropy is equals to product minus reactant. So we have 2 mole of carbon monoxide minus 1 mole of the carbon and plus 1 mole of carbon dioxide. So look at the balance equation. Look for the coefficient. Then we have 2 mole times 197.67. Then the unit minus 5.70 joule per joules per Kelvin times mole plus 213.74 joules per Kelvin times mole. Then the mole will be cancelled. So we have here 395.34 joule per Kelvin minus 219.48 joules per Kelvin, and the reaction is 175.86 joule per Kelvin. So meaning we have a positive entropy, meaning it is increasing. So can you answer this one? Try answering this one. You can pause and solve for this one. So now let's go to the Gibbs free energy or free energy. So this one is a criterion for a spontaneity that applies only to the system. It combines the enthalpy and the entropy. So meaning we have the change in free energy is equals to the change in enthalpy minus the temperature multiplied by the change in entropy. This equation is also known Gibbs equation. Change in free energy is used to determine whether a process is spontaneous. If the Gibbs free energy or the free energy is negative, the process will be spontaneous. If it is positive, it will be non-spontaneous, and if G is equal to 0, the system is equilibrium. So how and why? So these are the factors that affect the sign of our free energy in relationship to the Gibbs equation. So if we have positive enthalpy and positive entropy, so this reaction will also proceed spontaneously at high temperature. So at low temperature, the reaction is spontaneous, however, in the reverse direction. So if the enthalpy is positive, entropy is negative. But the free energy is always positive. That is why the reaction is spontaneous in the reverse direction at all temperatures. However, if the enthalpy is negative and the entropy is positive, then the free energy will be always negative, and the reaction will proceed spontaneously at all temperature. If both are negative, then the reaction will also proceed spontaneously at low temperature. And at high temperature, the reverse reaction becomes spontaneous. Proceed to the free energy and spontaneity of a reaction. So the free energy change for a reaction can be calculated by using the standard free energy of formation in the equation. So same with the enthalpy, we have summation of the product and summation of the reactant. The delta G to F is the standard free energy of formation of a compound.